Welcome back. Hope that little breather helped reset the brain and with good enough coffee. For this next segment, we'll bring another Boba Tea talk. This time with Phil Carrai, President of the Space Training and Cybersecurity Division at Kratos, hosted by Randall Barney, Executive Director of the World Teleport Association. Randy, Phil, please come to the stage.
Good afternoon, and welcome to our Boba Tea Talk. I'm Randall Barney, Executive Director of the World Teleport Association. I'm delighted to be joined today by someone who has been shaping the future of ground segment for years. Phil Carrai, President of the Space Training and Cybersecurity Division at Kratos Defense and Security Solutions. Phil brings more than 30 years of leadership across aerospace, defense, and advanced software systems. At Kratos, he leads work on software-defined ground systems, cybersecurity platforms, and simulation technologies that support both government and commercial space missions. Phil, thanks for being here.
Yeah, thank you, Randall. And I'm actually excited. We were just chatting about this Bobo tea. So pretty excited about that.
Okay, let's start with, from a wide lens. How are you seeing sovereignty emerge as a driver in the satellite industry?
So I think, if you go back 20, 30 years, obviously sovereign nations, governments from a defense and security perspective have always had an interest in space, have always had an interest in space being a mechanism, a way that they can communicate, within their country, communicate outside of their country, observe within their country, observe without their country. I think the challenge had always been the cost to do that was so substantial, only a handful of countries could afford what you would consider as sovereign assets. I think if you look at today, it's a combination of things, combination of the cost of spacecraft and the kinds of spacecraft have gone down with investments in mass manufacturing, small satellites, small spacecraft. The cost of launch has gone down, even if we've seen a consolidation of launch. Clearly, the cost of launch has gone down pretty dramatically, and the cost of some of the sensor packages or the quality of what those sensor packages can be that now can be put on these small spacecraft has gone to the point where you see many more nations capable of putting up and affording, and then secondly putting up sovereign assets. So, and I think the driver for that is control. Control of the data, control of security, control of the asset itself. So I think sort of the always desire to want to have that capability, and sort of always a government desire to control the environment around them for assets that they're using for an intelligence or a defense perspective, sort of coupled with what's happened with cost of all of the, if you will, kind of the supply chain of space, has got us to the point where sovereign assets are now achievable for many countries, where only 10 years ago, you only had a handful who could actually do space.
All right, let's break that down. Starting with satellite communications, software-defined satellites, 5G NTN, and GSO constellations, they're reshaping the landscape. What does that mean for from a sovereign ground perspective?
Yeah, and maybe kind of look at this from two perspectives, right? The amount of capacity that's available today is dramatic amount more than what was available even 5 years ago. And, sort of the big driver of that has been, the initial driver was high throughput satellites. The by far biggest driver has been the emergence of SpaceX and what Starlink has been able to provide globally from a capacity standpoint. I think as we see additional spacecraft come online, whether it's the new software-defined spacecraft, which again has the promise of decreasing the cost per bit and being able to configure the cost per bit, which is a challenge of today's geo spacecraft, along with other constellations that are coming online, whether it's Kuiper, whether it's Thousand Sails or other variants that are coming out of China, I think we'll continue to see sort of a dramatic increase in the amount of capacity that's available, and then the cost of that capacity continue to drop. I think as it relates back to the sovereign perspective and other things attached to the ground, there's always a desire to control what happens or what lands in my country. What lands in my country, how do I monetize spectrum rights, how do I provide spectrum rights, how do I secure my borders, is clearly a sovereign issue. And I think the sort of the coupling of dramatic increase in capacity and the kinds of capacity with the still requirement of what's happening in my region and how do I control that, I think we're just beginning to see the sorts of things that that we will need to have if you're a sovereign nation and you want to protect your borders, protect your spectrum, protect your sort of the economic rights you have relative to the spectrum you're using.
Great. Switching to Earth observation, the drive for data sovereignty is growing. Can you tell us what you are seeing in Asia and across the globe, and what is changing compared to past efforts?
Yeah, I think it goes back to the cost to launch, cost of spacecraft, cost of the sensor package being to the point where many sovereign nations are looking up at putting up their own sort of small constellations. And again, it's about control. I want to be able to land the data in my region, which is really a ground issue, right? How do I land the data in my region? I think the other thing we're seeing, particularly in Asia, is adoption of commercial imagers, or a hybrid of what a commercial imager is. The Planet transaction, and we're seeing others, right? Planet with JSAT for Japan, where you have a smaller sovereign constellation around the bigger global constellation that exists from a commercial imager, with the ability to land those images in region and be able to task, or at least partially task, what those what the payloads are looking at, and having you be the only one who knows what that tasking is. I think that's a very uniquely sovereign issue, and I think in Asia, again, the cost of putting up a global constellation, for many countries is prohibitive, but the cost of tapping into at least part of what a global constellation would look like, when it especially covers areas that you're concerned about outside of your region, along with a handful of imagers that are specific to the areas that you're interested in, can be very attractive. And again, I think unattainable just 5 or 6 years ago, but I think with the amount of commercial imagers that are out there, the quality of the images that we're seeing, and the changing business models, I think that we're beginning to see, from what used to be, we're going to provide data as a service, to now, essentially providing part of the constellation as a service. I think we're going to see more and more of that, along with sovereign launched capacity.
Can you discuss the growing importance of space domain awareness in today's increasingly congested and contested space environment in Asia?
Yeah, I think, it used to be you'd have a geo slot, when to get a geo slot, you'd station keep within a geo slot, and everything was oriented toward that. Now with with more geos, but honestly, proliferation at the LEO layer, and not just SpaceX. And here I'm talking about the imaging constellations, many imaging constellations that are sitting at the geo layer, many more that maybe are MEO or GEO, and of course at the geo layer as well. One element, there's a traffic control component of it, is how do you make sure that people are behaving correctly in the orbits that they have and not stomping on others, inhibiting others, jamming others inadvertently, because of where their spacecraft is. As one element of space domain awareness. To how do I protect those assets that I have, or the things that I'm downlinking to, I think is another big element of it, especially when you look at what people are doing on the imaging side of the fence, and potentially what countries are doing to prevent downlinking of that imaging. So I think, or sensing or the like. So I think like a sensing package or an airborne sensing package from a military perspective, we're trying to gauge who's coming into my country and how do I protect what I have. I think a sovereign nation wants to, first of all, that's why the ground sites are so important in their region, right? You want to get it down into your country and not anywhere else. It's kind of one element of it. And two, you want to make sure you protect that. And one of the ways you want to protect that is to understand what's happening at the space domain. And in this case, not just for the traffic management component of it, but for to understand what may be happening to those things that you're interested in downlinking from. So I think this protecting the signal, identifying when that signal is being disrupted, identifying when somebody's getting close to your spacecraft that you may not want to be close to yours. All of those things for many nations weren't an issue. They are now when you start putting your own spacecraft up, especially when you start putting your own sovereign spacecraft up. And lastly, especially when you're putting that sovereign spacecraft up for defense or intelligence purposes, all of a sudden you're now in a different world than many countries were when they were just doing communication.
Can you discuss the differences between the approaches to space domain awareness from optical to radar to RF, and talk about the need for monitoring beyond a country's borders to maintain sovereignty?
Yeah. So I think that, again, this is, if you look at ways you can determine what's happening with objects in space from the ground, you can use them. You can do a telescope, optical. You can do radar, or you can use RF. RF is another good way to talk about where objects are, identify objects, tag objects, each one with its own unique signature associated with it. We would argue that every one of those phenomenologies have benefit, and every one of them have some element of being unique in what you can offer. A non-object that isn't transmitting isn't necessarily something you're going to capture from RF. However, an object that is transmitting, you are going to be, or maneuvering and transmitting, you are going to be able to pick it up, whether it's sunlight or not sunlight. And the interesting thing that we're seeing, from our global sensor network is not a surprise. People understand, things that you're monitoring. Countries who have those things understand when they're being monitored, so they tend to maneuver in places where you may not be able to catch them. So maneuver in sunlight when you're occluded, or maneuver in other, maneuver when the sensor isn't there, isn't available to be monitored. So we think that sort of the full suite is really necessary for a sort of a complete situational awareness, or a complete awareness of what's happening to the space layer. And now, as it relates to the ground side and your borders, and we've seen this in a lot of areas, is that as we move into tighter and tighter beams, we talk about a Starlink, identifying a Starlink terminal. And how to identify a Starlink terminal and how close you need to be. If somebody's transmitting or managing in and around your borders, could be anywhere from 25 to 50 kilometers. That's a pretty tight area versus a wide beam spacecraft in terms of where you're going to monitor it. Now, I think if you look at what's happening with the software-defined spacecraft and GEO and how tight those beams are going to be as well, I think you're back into that same area, is that you really have to be close to the emitter to try to figure out who might be broadcasting, transmitting, doing things inside your border that you may not want to be doing, broadcasting and using your spectrum inside your border. So I think there's a whole new element of what needs to occur on the ground if you really want to sort of protect what's around you. And it has everything to do with the technology driving. It's funny, we're almost in this cyber world where there's an action, reaction, action, reaction. In the case of smaller, tighter beams, eliminating interference, getting more power to a given region, your ability to track and monitor that has changed dramatically as well from again, what we had in a wide beam spacecraft, 5, 10 years ago, even, what's up in the GEO arc today. So that whole element, I think, is part of what we're seeing sovereign nations look at in terms of how do I protect my borders? How do I make sure that my spectrum is being used appropriately? How do I make sure that there are people inside doing things that I don't want them to do?
Okay. And lastly, there are many factors to enabling sovereignty. One is ownership, which is pretty clear. Can you discuss the role of orchestration?
Yeah, I think these hybrid situations we're beginning to see is that orchestration. How do I take what might be a sovereign asset that I would launch as a country and then couple that with an as-a-service asset? I think in some respects, if you look at the ground-as-a-service providers today, they really started this trend of how do I take what is really a commercial system and use that commercial system to be able to serve a multitude of needs. Then the way that's done is by orchestrating from an enterprise perspective. What spacecraft do I need to communicate with, whether it's TT&C or whether it's an image downlink, or what do I need to communicate with, and how do I contend my antennas on the ground? All right, that's the business model of a ground as a service. How do I contend my infrastructure? But the only way you make that work is by orchestrating what your ground layer looks like. And I think if you throw on top of that sovereign assets or sovereign nations who also have capabilities on the ground that they may want to use only for in certain circumstances, and back to that element of control, there's at some point you want to make sure it's you and only you can use that asset, but space requires more of a footprint on the ground, more resiliency. So how do I sort of use maybe a government-specific asset with a commercial asset? How do we do that in combination? And I think that's where you get back into these hybrid models, where the economics work, both from a commercial standpoint and a government standpoint, and the security model works, I think, from a government standpoint and a commercial standpoint, where you get sort of that contention on the ground, which makes the model work for commercial companies, and the government gets their element of sovereignty along with whatever ownership they have and the assets, and that combination only works if you can orchestrate what your ground system looks like.
Phil, this has been a fascinating discussion. Sovereignty in space isn't just a matter of who launches satellites. It's about how ground systems, data, and networks are built and orchestrated. Thank you so much for your insights.
Yeah, thank you very much. Appreciate it.
Thank you, Phil, and thank you, Randy.